So the Chapter 5 review should just encompass everything that's test-worthy from Chapter 5. The first 3 problems we're going to be asked to sketch graphs, guaranteed to be a couple of these on the test. On the test, you'll get parts A through F that are described, and then you'll be given a graph that has the x and the y-axis marked out. So ultimately for this graph, when I go to enter it on my calculator, I'm going to have to enter x min of -7, x max of +7, and y min of -4, and y max of +4. Hopefully I haven't just rolled over a point that I need to graph here in a second. So the first thing I need to do for problem 1 is to find the x-intercepts. And for part 1a, it's super easy to find the x-intercepts because this is a factored polynomial. So to find the x-intercepts, I simply just take the polynomial and set it equal to 0. And because this is factored, there's not a lot of work. The x minus 5 squared, it might be worth my time to write it as x minus 5 times x minus 5. Now that I have it kind of completely expanded, at least into multiple parentheses, I can take each of the parentheses and set it equal to 0. Solve each for x. The first two I'll add 5 to both sides and get x equal to 5. The last one I'll add 3 to both sides and get x equal to 3. For my answer to part A, the x-intercepts are just going to be the points 5, 0 and 3, 0. That's half of the answer to part A. That's listing each x-intercept. I'm going to plot those on my graph with a dot. I'll make a dot at the point 5, 0, a dot at the point 3, 0. The other part of A that I haven't got to yet is the multiplicity. And the multiplicity is either the word even or odd, because there were 2 factors that gave the x-intercept of 5 and 2 is an even number. For the multiplicity under the 5, I'm going to write even. There was only 1 factor that gave the x-intercept of 3, and 1 is an odd number, so I'm going to say the multiplicity is odd. For part B of number 1, to determine whether the graph crosses or touches the x-axis, this graph at the point 5, 0, because it has even multiplicity, is going to touch the x-axis, and at the point 3, 0, because it has odd multiplicity, is going to cross the x-axis. So at the point 5, 0, the graph is going to reflect off of it. At the point 3, 0, the graph is going to cross. Part B, to do the maximum number of turning points, the maximum number of turning points you get by taking 1 minus the highest exponent when this whole polynomial is multiplied out. So in order to do 1c, I should expand a little bit this polynomial. So my f of x is equal to x minus 5 times x minus 5 times x minus 3. I'm going to FOIL this out. I'm going to multiply these 2 parentheses by FOILing. Get first our x squared. Outers are x times minus 5, which is minus 5x. Inners are minus 5x. Lasts are plus 25. So in the process of answering the question to part C, I need to know the highest exponent of the x that occurs when the polynomial is multiplied out. The first FOILing that I did should simplify to x squared minus 10x plus 25. And now I'm going to do x squared times x, x squared times minus 3, x squared, and then minus 10x times x, minus 10x times minus 3, 25 times x, and 25 times minus 3. When I multiply this whole polynomial out, the first term is going to be x cubed, and then I'm going to get a minus 3x squared, a minus 10x squared, a plus 30x, a plus 25x, and a minus 75. The maximum number of turning points is 1 minus the highest exponent when the problem is multiplied out. I don't need to simplify this anymore. I know the highest exponent is going to be x equal to 3. The maximum number of turning points is 1 less than the highest exponent, so there's going to be a maximum of 2 turning points. part D, I'm going to see all on my graph. On the graph, I'm going to label the x-intercepts and the turning points, and I can't do the turning points until I get this on my calculator. So part D is to sketch a graph. I'm going to graph using the window that I suggested, so let me change my window from -7 to 7 for the x's and -4 to 4 for the y's. You'll be given that window on the test, and I'll clear the function that's in there and enter this function, x minus 5 squared times x minus 3, graph it, and I need to get a real good estimate of the turning points. The turning point there is going to be, I don't know, and that's going to be the x-intercept of the point 50. This turning point, I know it's the point 50 because at the point 50 the graph crosses but doesn't touch the x-axis. It touches but doesn't cross the x-axis. That produces a turning point. That turning point's a maximum point. To find it, I go second in calc, go down to option 4 that says maximum, and then I start using my cursor. I need to get my cursor flashing on the screen somewheres close to that turning point but to the right of it. And that turning point there, finally got close to it. So I'm close to the turning point. I'm into the right of it. I'm going to hit enter. The word left bound is going to change to right bound. And I'm going to continue to trace. I'm going to get to the right of that turning point, which is a maximum point. Hit enter. The word right bound is going to change to guess. And then I'm going to get as close as I can to that turning point and hit enter. And it's going to give me that maximum point. I'm going to round that to 2 decimals. I'm going to round that to 3.67 and 1.19. So 3.67 and 1.19, maybe 3.67, 1.19 is the turning point. I'm going to write that on the graph. On the test, you should do the same. Write the 2 decimal version of the turning point on your calculator. Now I'm going to copy the graph. I know that that's the point 50 because when the graph touches but doesn't cross the x-axis, you get a turning point there. So my graph looks something like that. I've labeled my turning points. Maybe I get a little extreme with this bend. Maybe it should go up a little bit more, but we're not looking for that kind of precision. This is more than enough precision for this graph. So this is the answer to 1D. I sketched a graph. I probably, because it says to label the x-intercepts, should actually write what both the x-intercepts are. And it says to label the turning point, so I wrote what the turning point is. For part F, I want to describe the end behavior. So I look at the left half of the graph. Because the left half of the graph is getting lower, we're going to say it falls to the left. And the right half of the graph is going up. We're going to say it rises to the right. So again, if you haven't done the videos for this, this won't make any sense. This is just supposed to cement what you already know and fill in any holes that you might have. So for the end behavior, we look at the far left and the far right edge of the graph. If it's going down, it falls. If it's going up, it rises. Lastly, state the intervals where the graph is increasing and decreasing. To do that, on the x-axis, we put negative infinity, positive infinity, and the x-coordinate of any turning point, which is 3.67 and 5. We don't have to put the x-intercepts on unless they're turning points. So negative infinity, x-coordinate of the first turning point of 3.67, x-coordinate of the second turning point, which is 5, and positive infinity. This is going to imply the intervals from negative infinity to 3.67, all round brackets for these increasing and decreasing, and then 3.67 to 5, and then 5 to infinity. Probably should have did this in some other kind of color, but it is what it is. And now for each interval, I'll describe what it does. The portion of the graph that corresponds to this interval is that portion of the graph right here. And this graph, even though it's falling as I move, it's going down as I go backwards in some sense, it's increasing as I move from left to right. So for that interval, in part F, should I say, my answer, that interval, is going to be an increasing interval. And the lazy way to do the word increasing is just to do an arrow that points up. So from the start of the graph to the first turning point, the graph is increasing. And then between the first turning point and the second turning point, as I move from left to right, the graph is decreasing. That's that interval. So I'm going to say for the interval 3.67 to 5, the graph is decreasing with a down arrow. And then the last portion of the graph from the turning point at 5, 0 to the end of the graph, as I move from left to right, the graph is getting higher. So we'll say that graph is increasing in the interval from 5 to infinity. That's going to be the last part of my answer to question 1. So everything is more or less written here other than the graph with the turning points labeled. I have more on my graph than I probably really needed to show, but I needed these intervals to help myself through the other parts. So for question 2, the first thing I'm supposed to do in part A is to find the x-intercept and the multiplicity of each x-intercept. To find the x-intercept, you just take the function, in this case x squared plus 2x minus 15, and set it equal to 0. I'm going to do that by factoring. I'm going to go x plus 5 times x minus 3 equal to 0. I'll get x plus 5 equal to 0 and x minus 3 equal to 0. The x part of my x-intercepts are x equal to negative 5 and x equal to 3. So part of the answer for 2a, my x-intercept is going to be the point negative 5, 0 and positive 3, 0. Each one of these came from a factor that only had one factor. One is an odd number, so both of these have odd multiplicity. So done with 2a, I'm going to plot the point negative 5, 0 and positive 3, 0 on my x-axis. If you just plot them and don't write the point next to it, that's probably almost better because it keeps the graph a little bit cleaner. And if you have the correct answer, I'll realize that those are the points. Part B is determine whether the graph crosses or touches. With odd multiplicity, the graph crosses the x-axis. So as I go to do part B, it says determine whether the graph crosses or touches the x-axis. For both of these, because they both have odd multiplicity, the graph is going to cross the x-axis as opposed to touch. Part C is the maximum number of turning points. And the maximum number of turning points is the highest exponent minus 1 once the problem is multiplied out. This is already multiplied out, so the highest exponent is 2. The maximum number of turning points is 1 less than that, which is going to be 1. Part D is to sketch a graph, approximate the turning points. I'm going to do this all on the graph. I'm going to set my window up for success here, so I'm going to set the window up x min negative 7, x max positive 7, y min and y max negative and positive 18. You'll be given blank graphs that are marked out like this on the test, so you'll know exactly what your window should be. Now I'm going to enter the function x squared plus 2x minus 15, graph it. There's the point negative 5, 0. There's the point 3, 0. The turning point's a minimum point. I'm going to get that minimum point by going second calc, going down to option 3 that says minimum, hit enter, use my arrow and trace to the left of the vertex, so the left of the minimum point. Hit enter and the word left bound changes to right bound. And then I'm going to trace around past the vertex, get to the right of the vertex. Hit enter, the word right bound will change to guess, and then I'll get close to the vertex and hit enter, and I'll probably have to round the x coordinate because it doesn't do it exactly always. That turning point I'm going to say is the point negative 1, negative 16. I'm going to round that 0.9999 to negative 1. And so I'm going to say the turning point is negative 1, negative 16, and I'm going to actually draw that and label that point. So now I'm just going to draw my parabola. Looks enough like my calculator's picture that I feel good about my graph. Done with part D, so this is part D of number 2. Part E wants the end behavior. To do the end behavior, I look at the graph's far left edge and far right edge. If it's going towards positive infinity, we say it rises. If it's going towards negative infinity, we say it falls. Both sides of the graph are going up as opposed to going down towards positive infinity. So we're going to say it rises to the left, and it rises to the right. The last part that we have to do is the increasing and decreasing. That's for 2f. To do part f, I'm going to put negative infinity on the far left of the edge of the x-axis, and the x-coordinate of the turning point, -1, and positive infinity on the x-axis. I don't need the x-intercepts. The intervals that are going to be implied here, all round brackets for increasing and decreasing, are the intervals negative infinity to -1 and the interval -1 to infinity. When I go to do part f, I'm going to identify the interval that's increasing and the interval that's decreasing. The first interval corresponds to this part of the graph. Even though it rises to the left, as I move from left to right on the graph, it's going lower. That's going to be a decreasing interval. So in the interval from negative infinity to -1, I'm going to say decreasing. The portion of the graph that corresponds to the interval -1 to infinity is that interval here that as I move from left to right is getting higher, so it's increasing. So for my part f, the increasing and decreasing, it's increasing from -1 to infinity, it's decreasing from negative infinity to -1. All right, problem 3. First thing I want to do is find the x-intercepts and the multiplicity. So for my x-intercepts in problem 3, I set the function x cubed plus 2x squared minus 8x equal to 0. I'm going to solve this by factoring. I'm going to pull out a common factor of an x and get x times x squared plus 2x minus, 8, good, equal to 0. I started doing some math wrong in my head. And then I'm going to factor what's left in the parentheses. That factors into x plus 4 times x minus 2. I'm going to set each factor equal to 0. The first one gives me x equal to 0, which is going to be an x-intercept of 0, 0. The second bit of algebra gives me x equal -4, which gives me an x-intercept of -4, 0. The third bit of algebra gives me x equal to 2, which gives me an x-intercept of 2, 0. Each one of these factors only occurs once. Once is an odd number, so each one of these has odd multiplicities. So for part 3a, I needed to find each of the x-intercepts. Here are my x-intercepts. And I needed the multiplicity, and right under the x-intercept I wrote the multiplicity. The multiplicity is the word even or odd. I don't think I spelled that so well, but we'll live with that for now. Part B is we have to determine if the graph touches or crosses at the x-intercept. Because each of the x-intercept has odd multiplicity, the graph is going to cross or crosses the x-axis at that intercept. If an x-intercept had even multiplicity, the graph would touch but not cross the x-axis, and you get a turning point. So that's part B. Part C is the maximum number of turning points, and the maximum number of turning points is 1 less than the highest exponent if the polynomial is multiplied out. So for 3C, there's going to be a maximum of 2 turning points. I don't need to do anything but look at the highest exponent because that problem is multiplied out. Part D is to sketch a graph. So on my graph, I need to mark the x-intercept of 0, 0, -4, 0, +2, 0, set my window up, graph it, and find the turning points. So on y equals clear, the function I'm graphing is x up arrow 3 plus 2x squared minus 8x. The window I want is -10 to 10 on the x's and -20 to 20 on the y's, if I could actually do that right. When I hit graph, I should be able to see the turning points. I see 2 turning points. That turning point's a maximum point. I'm going to find that turning point by hitting second and trace, going down to option 4 that says maximum. Get my cursor to the left of the maximum point. Hit enter. Trace around, get my cursor to the right of the maximum point, hit enter. And I'm going to round this to 2 decimals. I'll trace close to the maximum point and hit enter. And I get -2.43, 16.9. So -2.43, 16.9 kind of crudely plotted is the first turning point, which is a maximum point, rounded to 2 decimals. The next turning point I'm going to get is a minimum point. To find it, I do second and trace, go down to option 3 that says minimum, trace and get your cursor to the left of that minimum point and hit enter, trace further and get to the right of that minimum point and hit enter, and then get close to that minimum point and hit enter. And I get 1 point, I'm going to round that to 1.10. The 7 rounds the 9 up to a 10, which rounds the 1 up to a 1. So I'm going to get 1.1 and negative 5.05. So 1.1, negative 5.05, really kind of crudely plotted. So I rounded each of the x and the y part of the turning point to 2 decimals. And now I'm just going to copy this graph. The graph goes through the x-intercepts, gets to the turning point, turns around, comes through the x-intercept, gets to the turning point, goes around and goes to the turning point. So this would be the answer for part 3D. This is sketching a graph and labeling the turning points. 3F wants the end behavior. So we look at the left edge of the graph. The left edge of the graph is going down towards negative infinity. So we'll say that that graph falls to the left. The right-hand part of the graph is getting higher as it goes to the right edge. We're going to say it rises to the right. Now I'm going to do the increasing and decreasing part, which is this was actually 3E. The falls to the left and rises to the right. The end behavior is 3E. And 3F is the increasing and decreasing. And in order to do 3F, I'm going to put negative infinity on the far left edge of my x-axis. The x-coordinate of each turning point, negative 2.43 and 1.10 on my x-axis in positive infinity. The intervals I'm going to create, all round parentheses, negative infinity to negative 2.43, negative 2.43 to 1.10, and 1.10 to infinity. The first interval corresponds to this portion of the graph, and as I move from left to right, that portion of the graph is getting higher. So that's going to go in the increasing interval. So the first interval, it's increasing. It goes with the up arrow of negative infinity to negative 2.43. The second region, negative 2.43 to 1.10, corresponds to that part of the graph, and as I move from left to right, it's getting lower. So that's going to be a decreasing interval. So negative 2.43 to 1.10 is going to be decreasing. And the last interval, 1.1 to infinity, corresponds to that portion of the graph, which is another increasing interval. I need to put a union symbol and then put that interval right after it. So the increasing is negative infinity to negative 2.43, union 1.10 to infinity. The decreasing is negative 2.43 to 1.10. All right, that's just the first 3 problems, and that's already 24 minutes. It's going to be a long review. So 4 and 5 are the synthetic division problems. Each problems 4 and 5 give us a cube, and in part A, they want us to use my graphing calculator to find any x-intercept of the polynomial. So to do part 4A, I'm going to graph this function, which is f of x equals x cubed plus x squared minus 9x minus 9. I'm going to zoom standard this. I don't need to see anything but the x-intercept. I see 3 x-intercepts. I like using positive ones. Let me go second in table. Any number in the x column that has a 0 next to it in the y column is suitable for this step, and I'm going to pick the positive 3. So my x-intercept that I'm going to pick is the 0.30. My answer to part 4A, the x-intercept that I'm going to pick is the 0.30, and that's going to help me do synthetic division. The synthetic division I'm going to do is going to have a 3 in the backwards L. And real specifically, the algebra that would produce an x-intercept of 3 would be x minus 3 equal to 0. If you set the x part of the x-intercept equal to x and set it equal to 0, you get x minus 3. So what the synthetic division is doing in problem 4b, the synthetic division is dividing x cubed plus x squared minus 9x minus 9 divided by x minus 3. If the synthetic division has a remainder of 0, it gives me a tool to factor the polynomial that I'm starting with. So let me get the synthetic division going. I'm going to pull off the coefficients of these numbers, so 1, 1, negative 9, and negative 9. I'm going to bring down the 1 and then multiply 1 times 3, or 3 times 1, and get a 3. I'm going to add this 1 and 3 and get a 4. Then I'm going to multiply the 3 times 4 and get a 12. These have opposite signs, so I'm going to subtract and take the sign of the larger and get a positive 3. And then I'm going to multiply 3 times 3 and get a 9, get a 0, which is the remainder. I start filling up x's with one exponent less than the original problem. So this is going to be a 1x squared plus 4x plus 3, remainder of 0. So the result of this synthetic division is x squared plus 4x plus 3. Anytime you do synthetic division and you get a remainder of 0, that means the numerator, in this case x cubed plus x squared minus 9x minus 9, equals to the denominator times the answer from the synthetic division. So synthetic division with a remainder of 0 gives me a tool to partially factor a polynomial. To completely factor this polynomial, which I needed to do in part B, I need to take the answer to the synthetic division and factor it. So my answer for 4b is going to be the polynomial f of x can factor into 3 parentheses. The first parenthesis is going to be an x minus 3. I got that from the x-intercept. The next 2 parentheses I get from the synthetic division. When I factor this down further, that factors into x plus 1 times x plus 3. So that would be considered completely factored. So I'm done with part A. I found an x-intercept. Part B, I used my x-intercept to create a division problem. I solved that division problem using synthetic division. Because I got a remainder of 0, the denominator times the answer equal the numerator, gave me a partial factoring of the polynomial. I completely factored it and finished the problem up. Part 4c, I'm supposed to solve f of x equal to 0. Well, since this is equal to f of x, I can change this problem to solving x minus 3 times x plus 1 times x plus 3 equal to 0, because that's just taking the f of x and replacing it with something it's equal to. So that's really saying x minus 3 equal to 0, x plus 1 equal to 0, and x plus 3 equal to 0. The first factor gives me x equal to 3. The middle factor gives me x equal to negative 1. The far right factor gives me x equal to negative 3. The answer to part 4c is just going to be those 3 numbers. I don't need to write them as x-intercepts. So I'm going to say my answer is going to be x equal to 3, negative 1, and negative 3. That's everything I needed to do for problem 4. I'll do the same thing for problem 5, but I'm going to need horrible bottoms-up factoring to finish it up on that step B. So first thing in 5, part A, find an x-intercept. I like positive x-intercepts if I can. And I get my intercept by sketching a graph. So I'm going to put the function in there, which is 4x up arrow 3 plus 8x squared minus 9x minus 18. Don't really care what the graph is. I just need to be able to find an x-intercept. And I need an x-intercept that doesn't have a fraction, so I go second in table. I see negative 2, 0. Don't see any more zeros that way. Don't see any more zeros that way. The only x-intercept that's quick to see is negative 2, 0. I'm going to use that even though it's a negative. And again, the algebra that would produce an x-intercept of negative 2, 0 would wind up at x equal to negative 2. and then if you add 2 to both sides, the algebra at some point may have said x plus 2 equal to 0. In 5b, I want to do synthetic division, and the synthetic division I'm going to do is going to divide the polynomial by x plus 2. And that's going to have a remainder of 0, which is going to help me factor that polynomial. To do the synthetic division, the x part of the x-intercept I put in a backwards L, and the coefficients I write across. So 4, 8, -9, and -18. Make my bar, bring down the first number, and then I multiply. -2 times 4 is -8. This is nice. I won't need bottoms up then. The 8's cancel and I get a 0. -2 times 0 is 0. -9 plus 0 is -9. And then -2 times -9 is positive 18. -18 plus positive 18 is 0. I start filling x's in, one exponent lower than the original problem, so I'm going to put a 4x squared plus 0x to the first minus 9, remainder of 0. The answer to my division problem is just 4x squared minus 9. And what that tells me is that the denominator times the answer equals the numerator. So that tells me that the numerator, 4x cubed plus 8x squared minus 9x minus 18 equals the denominator, x plus 2, times the answer, 4x squared minus 9. My answer for part B is I need to completely factor the polynomial. And I'm going to completely factor the polynomial by just finishing up this factoring here. So my answer to 5b, my function f of x can be written as x plus 2, and then I'm going to factor that, and that's just a difference of squares. So that's going to be 2x plus 3 and 2x minus 3. You just square root the numbers, and you divide the exponent of the letter by 2, and you get one parentheses with a plus, one with a minus. Done with 5b. 5c asks me to solve where f of x is equal to 0. I'm going to take this version of f of x and set it equal to 0. So I'm going to go x plus 2 times 2x plus 3 times 2x minus 3 equals to 0. When I set this equal to 0, I just need to go x plus 2 equal to 0, 2x plus 3 equal to 0, 2x minus 3 equal to 0. First factor gives me x equal to -2. The middle factor, you divide minus 3 from both sides and get 2x equal to minus 3. And then you divide by 2 and get x equal to minus 3/2. The last one, you add 3 to both sides and get 2x equal to 3. And then divide both sides by 2 and get x equal to 3/2. The answer to parts 5c, just going to be those three numbers that they don't need to be written as x-intercepts. So it's going to be x equal to -2, -3/2, and positive 3/2. You can write a plus or minus next to the 3/2 if you care to. Okay. Problem 6. Create a polynomial with degree 2 that has these zeros of x-intercepts of 3, 0, and -4, 0. So ultimately, I need to create a polynomial that has an highest exponent of an x squared that has x-intercepts of 3, 0, and -4, 0. The algebra that produces the x-intercept of 3, 0 would end up at x equal to 3, and right before it was x equal to 3, it would have been x minus 3 equal to 0. The algebra that would produce the x-intercept of -4, 0 would end up at x equal to -4, and before that, it would have said x plus 4 equal to 0. The polynomial that I need to create in problem 6 is just the product of these two factors, the x minus 3 factor times the x plus 4 factor. Once I FOIL this out and combine like terms, I'll get the answer that I'm looking for. So when I go to do this problem, I'm going to multiply this out because I was told to multiply this out. The first are x times x, which is x squared, The outers are x times 4, which is plus 4x. The inners are minus 3 times x, which is minus 3x. The lasts are minus 3 times 4, which is minus 12. And this whole thing would simplify to x squared plus x minus 12. That's going to be my answer to problem 6. Super easy to check these. To check these, just graph this function and make sure it has those x-intercepts. So it takes 2 seconds to check, so I'm going to check it. I'm going to hit my y equals. I'm going to enter the function x squared plus x minus 12. I'm going to graph it. And it looks like it has an x-intercept at negative 4 and positive 3. To confirm that, I'll peek at the table. Make sure next to negative 4 in the table I have a 0, which I do. So there's the x-intercept of negative 4, 0. And make sure next to 3 in the table I have a 0 in the y. And that confirms my intercepts. For problem 7, I need to create a function that has degree 3. So my answer in problem 7 is going to have a function, and the first term is going to have an exponent of 3. I need to create a function that has degree 3, so I need 3 zeros. I'm only given 2 zeros, but I should know that zeros with i's come in pairs. The fact that 4i is a 0 tells me that negative 4i is also a 0. Now I'm going to create the equations that would have created those zeros. So x equal to negative 5, x equal to 4i, and x equal to minus 4i are the equations that would have created those zeros. For this one, I'll add 5 to both sides, and x plus 5 equal to 0 would have been the step before I got x equal to negative 5. For this one, I'll minus 4i from both sides. X minus 4i equal to 0 would have created 4i. And for this one, I'll add 4i to both sides, and x plus 4i equal to 0 would have created that. The polynomial that I'm going to create is just the product of these 3 factors. It's so much better to do the i's first. I'm going to do them first to make my work easier. So I'm just going to multiply these 3 factors together. First thing I'm going to do is FOIL these 2 and keep that x plus 5 just hanging for a bit. So for this one, the first are going to be x times x, which is x squared. The outers are x times 4i, which I'll write as plus 4ix. The inners are minus 4i times x. I'll write that as minus 4ix. And the last are minus 4i times positive 4i. That's minus 16i squared. The outers and the inners are going to cancel, so I won't worry about those. The first is going to stay x squared. The last, I'm going to change the I squared to a negative 1. And the first 2 factors are going to turn into x squared plus 16. The x squared is just the x squared, and the minus 16 times minus 1 gives me a plus 16. So that's the beginning of my multiplying out to get my polynomial. And now I'm going to finish and FOIL one more time. First are going to be x squared times x, which is the x cubed that I need to get. Outers are going to be x squared times 5, which is going to be the 5x squared in my answer. Inners are going to be 16 times x. That's going to be a positive 16x. Lasts are going to be 16 times 5. And I think that's 80. My answer to this should be x cubed plus 5x squared plus 16x plus 80. And checking it's a little bit trickier. To check negative 5's right, I should be able to plug negative 5 in for these x's and get 0. So if I wanted to check my answer, if I change each one of these x's to negative 5 and did negative 5, up arrow 3, plus 5 times negative 5 squared, plus 16 times negative 5, plus 80. When I hit enter, if I get 0, I know that I'm partially correct. Now I need to do the same thing with 4i. Do parentheses 4 second and decimal for the I, up arrow cubed, plus 5 parentheses 4 second decimal for the I squared, plus 16 parentheses 4 second decimal for the I, plus 80. If when I hit enter I get 0, I know that my answer is correct for that. And I do. And I could do the same thing for the negative 4i. If the positive 4i check, the negative 4i is guaranteed to check. Oh, right. So there's 7. If it's not clear what the answer is, it's f of x equals x cubed plus 5x squared plus 16x plus 80. I kind of ran out of room on that 80.